The year is 1976. At Domodedovo Air Base, 30 kilometers south of Moscow, Soviet test pilot Alexander Fedotov sits in the cramped cockpit of a MiG-25 Foxbat, the fastest interceptor the Soviet Union has ever built. His mission briefing was clear. He must track and intercept the American reconnaissance aircraft that has been violating Soviet airspace with impunity for over a decade. That aircraft is the SR-71 Blackbird. Fedotov adjusts his pressure suit, checks his instruments, and waits for the signal. He has trained for this moment his entire career. The MiG-25 beneath him can reach Mach 3.2. Nothing in the sky should be untouchable. But as he would soon discover, the Americans had built something that defied every assumption Soviet engineers had made about the limits of flight. The development of the SR-71 Blackbird began in the late 1950s. Born from the mind of Clarence Kelly Johnson and his legendary Skunk Works team at Lockheed, the project emerged from a desperate need. American U-2 spy planes were being shot down over Soviet territory, most notably the incident involving Francis Gary Powers in 1960. The CIA needed something that could fly higher and faster than any missile or interceptor the Soviets possessed. Johnson's solution was audacious. He proposed an aircraft that would cruise at Mach 3.2 at altitudes above 80,000 feet. At those speeds and heights, the aircraft's skin would heat to over 600 degrees Fahrenheit. Traditional aluminum construction would melt under such stress. Johnson's team turned to titanium, a metal so difficult to work with that they had invented entirely new manufacturing processes. Ironically, much of the titanium was secretly purchased from the Soviet Union itself through shell companies, as the USSR was one of the few countries that produced it in sufficient quantities. The SR-71's first flight took place on December 22, 1964, at AirForce Plant 42 in Palmdale, California. Test pilot Bob Gillen pushed the throttles forward on the two massive Pratt and Whitney J-58 engines. The aircraft, painted in a dark blue that appeared almost black, accelerated down the runway. At 175 knots, Gillen pulled back on the stick. The Blackbird climbed steeply into the California sky. Even in these early test flights, it was clear that Lockheed had created something extraordinary. The aircraft handled smoothly despite its unconventional design. But the real test would come at altitude, where temperatures and pressures created an environment more similar to space than conventional flight. By 1966, the SR-71 was operational. Strategic Air Command deployed the first squadron to Beale Air Force Base in California. The aircraft's mission was reconnaissance over denied territory, primarily the Soviet Union, China, and other adversarial nations. The SR-71 carried an array of sophisticated cameras and sensors that could photograph 100,000 square miles of Earth's surface per hour. From 85,000 feet, its cameras could resolve objects as small as 12 inches across. But the aircraft's greatest defense was not stealth or electronic countermeasures. It was pure speed. When an SR-71 crew detected a surface-to-air missile launch, standard procedure was simple: accelerate. The aircraft would push past Mach 3.3 if needed. No missile in the Soviet arsenal could catch it. Major Brian Schul joined the SR-71 program in 1984 after recovering from severe burns sustained when his A-7 Corsair was shot down over Cambodia years earlier. His first flight in the Blackbird was a revelation. The pre-flight ritual alone took hours. Crews had donned specialized pressure suits similar to those worn by astronauts. The suits were necessary because at operational altitude, the cabin pressure was equivalent to being at 63,000 feet. Any suit rupture would be fatal. Schul and his reconnaissance systems officer, Walt Watson, would then conduct an exhaustive pre-flight check. Every system had to be perfect. There were no abort options once you were at Mach 3 over hostile territory. Schul remembers his first operational mission vividly. After takeoff from Beale, they headed north, climbing steadily. The SR-71 required aerial refueling immediately after takeoff because the fuel tanks leaked when the aircraft was cold. This was not a design flaw, but an intentional feature. At operational temperature, the titanium fuselage would expand, sealing the tanks. At lower temperatures, fuel simply dripped onto the tarmac. After refueling over the Pacific, Schul pointed the Blackbird's distinctive nose toward Soviet airspace. As they accelerated through Mach 1, then Mach 2, the sensation was unlike anything he had experienced in other aircraft. The ride smoothed out. At Mach 3, the Blackbird seemed to float on the edge of space. Below them, the curvature of the Earth was clearly visible. Above, the sky darkened to a deep purple, almost black. The Soviet response to the SR-71 was the MiG-25 Foxbat. Soviet intelligence had detected the development of the Blackbird in the early 1960s, and the order came down from the Kremlin to build an interceptor that could stop it. The McCoy and Gurevich Design Bureau took on the challenge. The result was an aircraft that prioritized speed above everything else. The MiG-25 could reach Mach 3.2 in level flight, making it one of the fastest operational aircraft ever built. It was armed with 4 massive R-40 air-to-air missiles designed to destroy high-altitude bombers. Soviet planners believed that if they could get a MiG-25 into position, the SR-71 would be vulnerable. Lieutenant Colonel Mikhail Miyagi became one of the most experienced MiG-25 pilots in the Soviet Air Force. Based at Kolovsky Air Base near Moscow, his unit's primary mission was air defense against high-altitude threats. In 1973, Miyagi received a classified briefing about American reconnaissance flights. The SR-71 had been operating along Soviet borders for years, sometimes penetrating airspace over the Baltic states and the Kola Peninsula. Soviet radar tracked these intrusions, but no interceptor had successfully engaged the Blackbird. Miyagi's squadron was tasked with changing that. The first attempted intercept came on a cold morning in January 1974. Radar detected an SR-71 approaching Soviet airspace over the Barents Sea. Miyagi scrambled immediately. The MiG-25 climbed rapidly, its powerful Tamansky R-15 engines pushing him back into his seat. At 40,000 feet, ground control provided vectors. The target was ahead, flying at approximately 80,000 feet. Miyagi pushed the MiG-25 higher, watching his altimeter climb past 50,000 feet, then 60,000. The aircraft was performing well, but already he could feel the sluggishness in the controls. At 70,000 feet, the air was so thin that the MiG-25's conventional flight surfaces were barely effective. The aircraft maintained altitude primarily through engine thrust rather than lift. Ground control updated the intercept coordinates. Miyagi armed his missiles and searched his radar scope. Nothing. The SR-71 was above him, beyond the reach of his radar. He pushed the throttles to maximum, climbing desperately. 75,000 feet. 78,000. The engines were screaming, consuming fuel at an alarming rate. His mission clock showed he had perhaps 2 more minutes before he would need to turn back. At 80,000 feet, the MiG-25 reached its absolute ceiling. The controls were nearly useless. Any aggressive maneuver would send the aircraft into a stall, and still the SR-71 was above him. Miyagi caught a brief glimpse through his canopy, a dark shape against the purple-black sky. Contrail streaming behind it. Then it was gone, accelerating eastward. He had failed. Back at the base, Miyagi debriefed with his squadron commander and intelligence officers. The frustration in the room was palpable. The MiG-25 had performed to specifications. The problem was that the SR-71's operational ceiling was simply higher than Soviet intelligence had estimated. The Americans were flying at 85,000 feet, possibly higher during certain mission profiles. At that altitude, the air density was so low that even the MiG-25's powerful engines could not generate enough thrust to climb further. Soviet engineers had built the fastest interceptor in the world, but the Americans had built something that flew where Soviet aircraft could not follow. The intelligence revelation about the SR-71's true capabilities sent shockwaves through Soviet military leadership. How could the Americans have achieved this? Soviet engineers pored over the limited data they had about the Blackbird, the titanium construction, the innovative engine design, the fuels. Everything about the SR-71 represented a technological leap that the Soviet Union was struggling to match. In classified memos, Soviet Air Defense Command acknowledged the uncomfortable truth. They had no effective counter to the SR-71. Missiles could not reach it. Interceptors could not catch it. The Americans had achieved something remarkable, a genuine technological advantage in one of the Cold War's most critical domains. For the SR-71 crews, the knowledge of Soviet attempts at interception was both thrilling and sobering. They knew they were operating at the edge of human capability in an aircraft that demanded perfection from its pilots. Captain Harold Buck Adams, who flew SR-71 missions over the Baltic in the mid-'70s, described the psychological pressure of these flights. You knew that somewhere below you, Soviet radar operators were tracking your every move. You knew that interceptors were scrambling trying to reach you. The mission required absolute focus. One mistake, one system failure, and you were in Soviet airspace in an aircraft that could not land anywhere except a handful of American bases. The nearest friendly territory might be hundreds of miles away, and you were traveling at over 3,000 feet per second. The SR-71's operational profile was carefully designed to maximize its advantages. Missions typically began with a subsonic climb to altitude after aerial refueling. Once at operational height, the aircraft would accelerate to cruise speed, typically Mach 3.1 or 3.2. The route would take them along hostile borders, cameras, and sensors recording everything below. If Soviet air defenses detected the aircraft and scrambled interceptors, the standard response was to monitor the threat but maintain course and speed. The SR-71's defensive systems could detect missile launches and hostile radar. If a surface-to-air missile was fired, the crew would accelerate to maximum speed, often reaching Mach 3.3 or higher. At those speeds, even the most advanced Soviet missiles could not catch up before running out of fuel. But the SR-71 was not invincible. The aircraft's titanium skin, while incredibly strong, was also brittle at certain temperatures. The thermal stress of repeatedly heating to 600 degrees and then cooling caused cumulative damage. Maintenance crews at Beale Air Force Base developed extensive inspection protocols. After every mission, the aircraft underwent detailed examination. Cracks in the fuselage were not uncommon and had to be carefully repaired. The engines, too, required constant attention. The J-58 was a marvel of engineering, capable of operating efficiently at speeds where traditional jet engines would fail. But this performance came at a cost. Engine failures were rare but catastrophic when they occurred. In 1981, an SR-71 suffered a catastrophic failure over the Pacific during a training mission. The crew, Major Danhouse and his RSO, experienced an unstart, a violent disruption of airflow through the engine that generated tremendous forces on the aircraft. At Mach 3, an unstart could tear the aircraft apart. House fought to maintain control as the Blackbird yawed violently. The standard procedure was to reduce speed and restart the affected engine, but at their altitude and speed, they were seconds away from disaster. House managed to stabilize the aircraft and execute an emergency descent. They landed at a divert base with one engine barely functioning. The incident was a stark reminder that even the world's most advanced aircraft operated within narrow margins of safety. Soviet intelligence agencies were desperate for detailed information about the SR-71. The aircraft represented a significant intelligence gap. The KGB and GRU devoted substantial resources to understanding the Blackbird's capabilities. They analyzed radar returns, studied photographs obtained through espionage, and debriefed every pilot who had attempted an intercept. The picture that emerged was troubling. The SR-71 was not just fast. It was operating a flight regime that Soviet engineers had thought was impractical for sustained operations. The thermal stresses alone should have limited its operational envelope, but the Americans had solved problems that Soviet metallurgists were still struggling with. In 1976, they received an unexpected gift. Viktor Belenko, a Soviet pilot, defected to Japan in a MiG-25. Belenko's defection was motivated by disillusionment with the Soviet system, but the intelligence windfall for the West was enormous. American and Japanese engineers disassembled Belenko's MiG-25, examining every component. The process took months. Every system was photographed, measured, and tested. What they found was revealing. The MiG-25 was technologically impressive in some ways, particularly its raw speed capability, but it was also crude by Western standards. The airframe was constructed from nickel steel rather than titanium, making it heavy and limiting maneuverability. The electronics were based on vacuum tube technology rather than transistors. This was a deliberate choice by Soviet designers who believed tubes were more resistant to electromagnetic pulse effects, but which made the aircraft systems bulky and power-hungry. Belenko himself provided detailed testimony about Soviet air defense doctrine and the specific challenges of intercepting the SR-71. He described multiple briefings where intelligence officers had shown pilots grainy photographs of the Blackbird and explained its estimated capabilities. The number seemed almost impossible. Mach 3.2 sustained cruise, operational ceiling of 80,000 feet or higher, range measured in thousands of miles. Soviet pilots were told that interception was possible if everything went perfectly. If the SR-71 was detected early, if the MiG-25 could climb to intercept altitude with sufficient fuel remaining, if the American aircraft did not accelerate away. Too many ifs, Belenko recalled. Every experienced pilot knew it was nearly hopeless. But we tried anyway because those were our orders and our duty. Belenko's testimony confirmed what American intelligence had suspected. The MiG-25 could not effectively engage the SR-71 at operational altitude. The altitude difference was simply too great. Belenko's testimony also revealed the psychological impact on Soviet pilots. They were flying the fastest interceptor in the world, and yet they felt helpless against the American reconnaissance aircraft that routinely penetrated their airspace. The relationship between the SR-71 and MiG-25 represented a broader dynamic of the Cold War. Action and reaction, innovation and counter-innovation. Both aircraft pushed the boundaries of technology. Both represented massive investments by their respective nations. But the SR-71 held a crucial advantage: altitude. The Americans had correctly identified that extreme altitude combined with speed provided the best defense. The Soviets had focused on speed, assuming that altitude would follow naturally. This assumption proved incorrect. The SR-71's ability to operate at 85,000 feet placed it in a realm where physics worked against any pursuer. The air was too thin for effective maneuvering. Engines struggled to produce thrust. Missiles lost tracking ability. By the mid-1980s, the Cold War was beginning to thaw, but SR-71 operations continued. The aircraft flew missions over the Baltic, monitoring Soviet naval bases. It flew over the Middle East during regional conflicts. It conducted reconnaissance along the Chinese border. Every mission added to an ever-growing archive of intelligence imagery. The SR-71 had photographed virtually every significant military installation in the Soviet Union and its allies. This intelligence was invaluable for American strategic planning, providing detailed assessments of Soviet military capabilities. Major Brian Schul's most memorable mission came in 1986. Flying a route that took him along the Soviet Far East, he and his RSO conducted a standard reconnaissance run. Soviet radar tracked them continuously, and ground control reported multiple intercept attempts by MiG-25s and later MiG-31s, an improved successor to the Foxbat. None came close. Schul maintained Mach 3.2 at 85,000 feet. Below him, Soviet interceptors strained to climb, their pilots pushing their aircraft to the limits. Schul could monitor their radio communications through his electronic warfare systems. The frustration was evident even across the language barrier. The Soviet pilots knew they were being observed, knew that American cameras were documenting everything, and there was nothing they could do about it. The MiG-31, introduced in the early 1980s, represented a Soviet attempt to finally counter the SR-71. The aircraft incorporated more advanced radar and avionics, longer-range missiles, and improved high-altitude performance. On paper, the MiG-31 could reach 82,000 feet, closer to the SR-71's operational ceiling. But operational testing revealed the same fundamental problem. Even at maximum altitude, the MiG-31 could not maneuver effectively enough to engage a target. The SR-71 could detect the interceptor long before it was in weapons range and simply accelerate away. The speed difference, even if small in absolute terms, was decisive when combined with the SR-71's altitude advantage. Soviet air defense commanders eventually developed a grudging respect for the SR-71. In internal documents declassified after the Cold War, Soviet military analysts acknowledged that the Blackbird was effectively untouchable by conventional air defense means. They explored various options for countering it, including developing specialized high-altitude missiles and even considering the use of nuclear-tipped air-to-air missiles in wartime. But none of these solutions were practical or reliable. The SR-71 had created a significant asymmetry in reconnaissance capabilities. The Soviets could observe American territory through satellites, but the resolution and flexibility of the SR-71's cameras provided intelligence that satellites could not match. The human element of these encounters was complex. American SR-71 crews did not see themselves as invulnerable heroes. They understood the risks. They respected the skill of Soviet pilots who were trying desperately to intercept them. Captain Jim Shelton, who flew 32 SR-71 missions between 1980 and 1985, spoke about this in later interviews. He said that every time Soviet interceptors scrambled, he felt the weight of responsibility. If something went wrong, if the aircraft malfunctioned, he and his RSO would be at the mercy of Soviet air defenses deep in hostile territory. The ejection seats were effective up to 50,000 feet, but at operational altitude, survival odds were low. A pressure suit failure at 85,000 feet meant death within seconds. Soviet pilots, for their part, took pride in their attempts to engage the SR-71. Even when unsuccessful, Lieutenant Colonel Alexander Bazanov flew dozens of intercept sorties in both the MiG-25 and MiG-31. In post-Soviet interviews, he described the challenge with a mix of frustration and professional respect. The Americans had built a remarkable machine, he said. As a pilot, you could not help but admire the engineering achievement, even as you tried to shoot it down. Bazanov noted that the intercept attempts served a purpose beyond the immediate goal of downing the aircraft. They provided training for Soviet pilots in high-altitude intercepts and generated data about the SR-71's performance that intelligence agencies analyzed carefully. The SR-71 program was expensive to operate. Each aircraft cost over $34 million to build in 1966. Operating costs were similarly high. The specialized fuel JP-7 was expensive to produce and required careful handling. The pilots and reconnaissance systems officers underwent extensive training, often taking years to become fully qualified. Maintenance required specialized facilities and highly trained technicians. By the mid-1980s, some in the Air Force questioned whether the program was worth the expense, especially as satellite technology improved. But the SR-71's defenders argued that the aircraft provided capabilities that satellites could not. Satellites followed predictable orbits. Adversaries knew when they would pass overhead and could hide or camouflage sensitive activities. The SR-71 could fly missions on short notice, providing intelligence when it was needed rather than when a satellite happened to be in position. During the 1986 bombing of Libya, SR-71s flew pre-strike reconnaissance missions, providing crucial intelligence about Libyan air defenses. During the Iran-Iraq War, Blackbirds monitored both sides, providing American policymakers with detailed assessments of military capabilities and intentions. The Cold War then did not immediately retire the SR-71. The aircraft continued to fly missions into the early 1990s, but budget pressures and the development of reconnaissance satellites and unmanned aerial vehicles eventually led to the program's termination. The last operational SR-71 mission was flown in 1999. The aircraft had flown for over 30 years without a single loss to enemy action. Missiles had been fired at SR-71s on numerous occasions, but none had ever successfully engaged the aircraft. This record was unprecedented. No other military aircraft operating in hostile airspace could claim such invulnerability. The retirement of the SR-71 marked the end of an era in aviation. The aircraft represented a philosophy of reconnaissance that prioritized human crews, direct observation, and the ability to respond flexibly to intelligence requirements. The decision to retire the program was controversial. Supporters argued that the SR-71 provided unique capabilities that could not be replicated by satellites. Critics pointed to the high operational costs. The final years of SR-71 operations saw some of the most challenging missions. In 1990, During Operation Desert Shield, SR-71s flew missions over Iraq, providing pre-war intelligence about Iraqi military positions. Iraqi air defenses, while substantial, never came close to engaging the Blackbird. Modern reconnaissance relies heavily on unmanned systems and satellites. These platforms are effective and cost-efficient, but they lack some of the capabilities that the SR-71 provided. An SR-71 crew could make real-time decisions about targets of interest, could adjust their route to investigate unexpected findings, and could provide immediate feedback to intelligence analysts. Satellites follow predetermined orbits. Unmanned systems have limited endurance at high altitude. The Blackbird could fly a mission profile tailored to specific intelligence requirements and return with imagery and data within hours of collection. For the men who flew the SR-71, the aircraft was more than a machine. It was a partner in some of the most dangerous missions of the Cold War. Major Brian Schule, reflecting on his time in the program, described the Blackbird as the most remarkable aircraft he ever flew. The combination of speed, altitude, and capability was unique. Every flight was an adventure, a journey to the edge of the atmosphere and back. The trust between pilot and reconnaissance systems officer was absolute. They depended on each other completely at altitudes where a single mistake could be fatal. Soviet pilots who tried to intercept the SR-71 had their own reflections. Lieutenant Colonel Mikhail Miyagi, interviewed in the 1990s after the Soviet Union's collapse, spoke with surprising candor. He acknowledged that every intercept attempt had failed. The SR-71 was simply beyond the reach of Soviet air defenses during that era. But he also noted that these missions had been valuable. They pushed Soviet pilots and aircraft to their limits, revealing capabilities and limitations that intelligence could use. And they sent a message to the Americans that Soviet air defenses were active and watching. The technical competition between the SR-71 and MiG-25 drove innovation on both sides. American engineers continually improved the Blackbird systems. Soviet engineers, stung by their inability to counter the SR-71, developed new air defense systems and interceptors. The MiG-31, while unable to catch the Blackbird, was a significantly more capable aircraft than the MiG-25 and went on to serve as the backbone of Soviet and Russian air defense for decades. The lessons learned from trying to intercept the SR-71 influenced Soviet thinking about future aircraft design and air defense doctrine. The SR-71's legacy extends beyond its operational achievements. The aircraft demonstrated what was possible when engineering excellence, innovative thinking, and substantial resources were combined with clear mission objective. Kelly Johnson and the Skunk Works team created an aircraft that remained cutting edge for 3 decades. The technical challenges they overcame were extraordinary. Working with titanium required developing new tools, new manufacturing processes, and new quality control methods. The J-58 engines were a marvel in their own right. Designed by Pratt & Whitney, these engines had to operate efficiently from subsonic speeds to Mach 3.2. This required an innovative variable geometry inlet system. At high speeds, most of the thrust actually came from the inlet itself, which acted like a ramjet. No other reconnaissance aircraft before or since has matched the SR-71's combination of speed, altitude, and range. The Blackbird proved that manned aircraft could operate in the most hostile environments and return safely, provided they had the right combination of capabilities. The aircraft defensive philosophy was elegantly simple: be too high and too fast to catch. This worked because the Americans had correctly identified the performance envelope where physics worked in their favor. Today, several SR-71s are preserved in museums across the United States. These aircraft, no longer shrouded in secrecy, allow the public to see up close what was once one of America's most classified programs. Standing next to an SR-71, the aircraft's size and sleek design are striking. The dark blue titanium skin, designed to dissipate heat, give the aircraft an otherworldly appearance. The twin engines, massive even by modern standards, hint at the power required to push the aircraft through the sound barrier and beyond. For historians of the Cold War, the story of the SR-71 and MiG-25 represents a microcosm of the larger conflict. Both superpowers invested enormous resources in achieving technological superiority. Both developed remarkable capabilities. But the SR-71 sustained operational success, flying missions over hostile territory for 3 decades without loss, represented a clear American advantage in this particular domain. It was a victory not of ideology but of engineering, of innovative thinking applied to a specific problem. The pilots and crew members who operated these aircraft, both American and Soviet, were professionals carrying out their duties in service of their countries. Many have spoken in later years about the mutual respect that existed between Cold War aviators. They were adversaries, certainly, but they were also fellow pilots who understood the challenges and dangers of flying high-performance aircraft at the edge of the atmosphere. The story of how the SR-71 repeatedly evaded Soviet interceptors is more than just a tale of technological superiority. It is a story about the men who flew these missions, about the engineers who designed impossible aircraft, and about a period in history when the competition between two superpowers drove innovation at a pace rarely seen before or since. The Cold War was fought on many fronts. In the skies of the Soviet Union, at altitudes where the sky turns black and the Earth's curvature is visible, the SR-71 Blackbird proved that in at least one arena, American technology had achieved something truly remarkable. The records from those decades reveal just how many times Soviet pilots attempted to intercept the SR-71. Dozens of scrambles, hundreds of hours of high-altitude pursuit, and every time the same result. The Blackbird was simply too high and too fast. The intelligence gathered by the SR-71 played a crucial role in American understanding of Soviet military capabilities throughout the Cold War. The photographs and sensor data collected during these missions informed decisions at the highest levels of government. In an era before the internet, before real-time satellite imagery was common, the SR-71 provided windows into closed societies that were otherwise difficult to observe. As the years passed and the Cold War receded into history, both American and Soviet participants in these high-altitude encounters have been able to speak more freely about their experiences. What emerges from their accounts is a picture of professional military personnel on both sides doing difficult and dangerous work. The Americans who flew the SR-71 described the aircraft with genuine affection and respect. The Soviets who tried to stop them speak with a mix of frustration at their failures and admiration for the engineering achievement they were facing. Technology has moved on since the SR-71's retirement. Modern reconnaissance satellites can provide high-resolution imagery. Unmanned aerial vehicles can loiter over targets. But for those who flew the Blackbird and those who tried to intercept it, the aircraft remains a symbol of a unique moment in aviation history when human pilots pushed the absolute limits of flight. The MiG-25 pilots who pursued the SR-71 never succeeded in their mission, but their attempts were not failures in the broader sense. They demonstrated the Soviet commitment to defending their airspace and pushed their aircraft to perform at the very edge of their capabilities. The intelligence gained from these intercept attempts helped Soviet engineers understand what would be required to counter future threats. And in a strange way, the persistent Soviet efforts to intercept the Blackbird validated the American investment in the aircraft. The final chapter of the SR-71 story includes an interesting postscript. In the late 1990s, NASA operated 2 SR-71s for high-altitude research. These aircraft, no longer needed for reconnaissance, provided a platform for atmospheric research and tested technologies for future hypersonic aircraft. Even in retirement, the Blackbird continued to push boundaries and contribute to aviation knowledge. The last NASA SR-71 flight occurred in October 1999, finally ending the aircraft's operational career after 35 years. Looking back at the Cold War competition between the SR-71 and the MiG-25, we can see it as a defining example of how technological innovation can create asymmetric advantages. The Soviets built an aircraft that met the specifications they believed necessary to counter the American threat, but the Americans had quietly exceeded those specifications, creating an aircraft that operated in a performance envelope the Soviets had not fully anticipated. This pattern repeated throughout the Cold War in various domains. For Major Brian Schul and the other SR-71 pilots who flew operational missions, the knowledge that Soviet interceptors were always trying but never succeeding created a unique psychological dynamic. There was pride in flying an aircraft that was effectively untouchable, but there was also constant awareness that any mechanical failure, any mistake, could put you in an impossible situation. The pressure suits they wore, the extensive pre-flight checks, the careful mission planning, all were reminders that they were operating at the very edge of what was survivable. Soviet pilots like Mikhail Miyagi had their own pressures. They knew that their efforts were being watched by their superiors, that their failures to intercept the SR-71 were documented and analyzed. But they also knew that they were being asked to do something that was, given the technology available, nearly impossible. The MiG-25 was an excellent aircraft within its design parameters, but those parameters simply did not extend to effective engagement at 85,000 feet. Yet they kept trying mission after mission because that was their duty. That moment of interception never came. Over more than 3 decades of operational flights, no SR-71 was ever damaged by enemy action. This remarkable record stands as testimony to the aircraft's capabilities, to the skill of the crews who flew it, and to the effectiveness of the tactics developed to exploit its advantages. The SR-71 flew into the most heavily defended airspace in the world and returned safely every single time. It is a record unlikely ever to be matched by a manned reconnaissance aircraft. The strategic implications of the SR-71's success extended throughout the Cold War. American intelligence agencies gained insights into Soviet military capabilities that would have been impossible to obtain through other means. This intelligence informed arms control negotiations, military planning, and diplomatic strategy. The SR-71 gave American policymakers confidence that they understood Soviet capabilities accurately, reducing the risk of miscalculation. For the Soviet Union, the inability to counter the SR-71 was a source of ongoing frustration and concern. It represented a gap in their air defense network, a vulnerability that Soviet military planners had to acknowledge. This drove continued investment in air defense systems and interceptor development. The arms race, of which the SR-71 and MiG-25 were just one small part, imposed costs that both superpowers struggled to bear. But the legacy of this competition is visible in the technological leaps that were made. The story of the SR-71 and the MiG-25 pilots, who could never quite reach it, remains compelling decades after the Cold War ended because it tells a story of human determination. It tells us about the limits of engineering and the drive to push past them. And it tells us about a time when the sky was the ultimate frontier of a global struggle for supremacy, a struggle played out at 3 times the speed of sound at the very edge of space.